Hello everyone, this is Group 5 and I'm here to throw some light on 8051 port programming and SFR registers. Now that's what I was talking about. As you can see here, it has got 40 pins, out of which maximum are labeled as either P0, P1, P2 or P3. They are what we call ports of microcontroller. These ports are just like mouth or ears of yours. They also help us in either listening or now let us first talk about port 0. It occupies 8 pins from pin 32 to 39. By default on reset, port 0 acts as an output port. For making it work as an input port, one have to write 1 to all the bits first. This could be done by simply moving FF to port 0. The most important thing about port 0 is its dual nature. It can be used to transmit address as well as data bits. To distinguish between both, we use a signal called address latch enable, that is ALE. It works like this. When ALE is high, that is 1, it facilitates address bits, and when ALE is low, that is 0. It entertains data bits. Now coming on to port 1, it also contains 8 pins from pin 1 to pin 8. By default, just like port 0, port 1 is also an output port, and can be converted to input as described in case of port 0. Only difference here is that in port 1 we do not require resistors in making it is because in case of port 0, it was opened random like P1, P2, P3, so we have to connect resistor up to 10 kilo ohm. Okay, I am leaving, do not create an issue. Now let us talk about port 2. Talking about port 2, there is nothing new in port 2 from port 1. Wait, there is one big difference, its dual nature. Port 2 is also used to carry higher bits of 16-bit address. That is why it is also designated as A8 to A15. Now talking about port 3, it can also be used as input and output port as other ports, but wait, there's one secret. Actually, port 3 has some special and additional task to do. It is used for providing important signals. Signals like these find their way through port 3. Here RXD is receiving bit. TXD is a transmitting bit. INT0 and INT1 are external interrupt bits. T0 and T1 are timer interrupt pins. And finally we have read and write signals. We have till now covered details about port of 8051. I think I am feeling tired and sleepy. Rest we will discuss tomorrow morning, everyone. By the way, where were we last night? Oh yes, we have to discuss about SFR registers. Before we move on to SFR, let's just first talk about general RAM memory and registers. Oh yes, this is what I was actually talking about. What here you can see is 128 bytes of internal RAM memory of 8051 architecture. Here you can observe register banks, some space for bit addressable memory, used for storing bit variables, and at the top scratch pad area. But wait, I cannot see accumulator, and registers like B, PSW, DPTR. Do they even have a separate address? Yes, they do have separate addresses. They are actually part of special function registers. Bingo! You got it right. These are the registers we were talking about, the special function registers. Here you can see sets of special function registers in 8051. For example, we have accumulator at E0, TCON at 88H and similarly others. Note how these two functions means the same. Thus these registers can be replaced by their address. However, their name symbols are used more frequently. Few things to notice here is, firstly, their address range lies in between 80H to FFH just after the 128-byte RAM memory. Secondly, not all the space in between the address range of 80H to FFH is utilized by SFR registers. I think I am forgetting one last thing. Oh yeah, I got it. Never try to use that reserved spaces in the between 80H to FFH. They are not for programmers.